the thing to go live. Are we gonna live? Are we gonna live the dream with the public today?
Yeah, I feel like if there's one thing that describes our podcast, it's living the dream.
Is the
right?
What dream? Let's have a dream-based episode. Let's have a dream theme.
I don't really remember dreams. Can't really.
Do you not?
I mean,
see, I'm a pretty good dream rememberer.
No,
someone I was speaking with the other day was surprised to hear that I lucid dream fairly often, like multiple times per week.
Well, so I don't really know what a lucid dream is.
That is a dream in which, and I know nothing about dream science, but I have been told it is a dream in which you recognize that you're dreaming and thus can control the things going on in your dream.
Huh. Yeah, no, I don't think I've ever done that.
Really?
I mean, unless I'm just missing it and that's actually just when I think I'm awake, that's what's actually happening.
Okay. We're getting a bit out here. Hello, dearies.
Sometimes I suddenly feel like, what? How did I get here? Maybe I've actually been asleep.
Oh man! One day he woke up and he was inside of that really cool secret cupboard behind him, disguised as a bookshelf.
Yeah.
You ready? You ready to do this thing? Or?
Yeah, we're doing it already, aren't we? It's too late to back down now.
Hello, dearies. Welcome to Undersampled Radio, episode, as I believe, 87. Is that right, Matt? Yes?
Yeah, plus or minus.
Yeah, whatever. Okay, so no fireworks for you today, folks. We are not at episode 100, but we are preparing the 911 call for that day. We have an exciting episode for you today because basically we were really bad at planning this episode and show notes. So with no further ado, I'm going to let Matt give an introduction to the show notes. What's happening in the world, Matt? Told in the theme of dreams, by the way.
I think I just blacked out there for a second, or my internet did. It's funny when you're speaking, Graham, because the projector's pointing directly at us, at the camera.
Is it
right? It gives me this weird impression that like somehow we're a projection.
I like it. Thank you.
Anyway,
sticking with the theme.
There's some sort of Inception thing going on. Who are we really? Yeah, well, not too much. I see you've got some proto benchmark data sets. Yeah, there has been some benchmark action. I think it's all been in the machine learning channel in Software Underground. Lucas Mossa stays on top of the archive pretty effectively and has posted a couple of papers recently, about maybe a week ago, 2 weeks ago, where people are publishing what I guess they hope will become benchmark data sets for Penobscot. And recently there was also a data set on the F3 seismic cube. Yeah, and they've basically done some interpretation, they're sort of zone-based interpretations. So it's like layers. They're fairly gross intervals. There's maybe 6 or 8 of them in the whole cube. And it looks kind of interesting. And then they've sort of, I guess, done some kind of neural net implementation to try to predict those intervals. They've used them as labels, which, sounds reasonable. But I've been a bit lukewarm about them because, well, they're just interpretations, right? So you can, even the sort of 1 or 2 sections that they publish in the paper, I look at it and go, well, I wouldn't have interpreted like that. So that's obviously an issue, the subjectivity of the labels. and then it feels a little bit sort of, I don't know, a little bit circular. Like, let's label up something that the machine can then predict. I don't know. So I'm not sure how I feel about them yet, but I haven't downloaded them to look at them. I've just looked at these papers. Did you take a look?
No, I did not. But here's something for you to consider that we've been thinking about recently, which is, if you have some sort of subjective labeling system, can you eventually increase the convergence to reality if you have, like, at a future time state, some fresher label eventually converging on what is presumably truth? So for instance, if you had an interpretation, built a model to predict that interpretation, then at a later time updated the so-called labels of it closer and closer towards reality. Let's say in this case, as you drilled wells, I suppose, your interpretation would get better and better.
Have you, so that reminds me of this, the image of this black hole at the center of M87. Have you looked at that very much?
It has been contaminating many a Slack channel.
Yeah. But have you read much about the method of image reconstruction?
Nope.
It's quite interesting. The woman that's been I guess getting some of the attention for coming up with the algorithm did a TED talk on it a little while ago, which was nice because it's very accessible because it's not too technical, and she does a really good job of well, not dumbing it down exactly, but just explaining in sort of layman's terms how the algorithm works. And I mean, fundamentally, it's it's that they've got this sparsely sampled image, and then they try to reconstruct plausible images, because it's a completely ill-posed problem, right? So there's an infinite number of solutions that will match the observations, because they've got observations from, what is it, like 7 or 9 radio telescopes, I think, at multiple points through time. So it's not just literally 7 or 9 points. It's like lots of points in there, because the Earth's rotating. They're sort of low-key of observations, but still it's really sparse. But what they do is they essentially sort of trained a model to, that knows what images look like, sort of thing. And they trained different models on, like, images from simulated black holes, astronomical images in general, and then completely general images of natural scenes. And the idea is that if those models predict similar things, then probably your image is reasonable, right? Because they've got different priors. If they sort of have convergent, like if they agree, then it seems reasonable to sort of suppose that it might be a good reconstruction, because then they're not too biased by what they sort of know about.
Makes sense.
Yeah. So yeah, there's an example of somebody trying to image something which you don't know what it is, but you know what kind of characteristics it has, and so you can kind of bootstrap, given some data, you can kind of inch your way towards plausible reconstructions, which is a bit like what we're trying to do with geology, right?
Yep.
Yeah, I like the idea of anything sort of iterative. I also, because like we've relaunched Pick This recently, wonder if you can just get lots of different opinions. How can you sample the solution space, so to speak, and not have to rely on a single interpretation as a bunch of labels? Anyway, we'll see what the community makes of these benchmarks, I guess.
Cool.
The only one that's really taken off, the only benchmark in our space that's really taken off, is the one from Brendan's paper, you know,
Yeah.
the leading edge, like October 2016, I think it was. And you know, that's not an open data set, unfortunately. So it's like, but it's been getting used over and over and over again. It's been in dozens of papers already. So I guess that's what will happen, is the community will decide if they like it or not,
and off it will ship.
Yeah.
Cool. Want to introduce our guest today?
Yeah, sure. Bane. So Bane Sullivan, to be honest, I only know through the Software Underground, and he's especially popped up around anything to do with sort of visualization, and especially 3D viz. And you know, so we did the hackathon on visualization. Was that last year? Yeah, it was. Was that last year? Oh my God, that seems like an age ago, but yeah, I guess it was last year. And you know, so since, and then I think that was roughly when the Viz channel started. And yeah, I just because he's involved in a couple of interesting sounding open projects that sort of revolve around VTK and that framework. And because the question of how do I visualize this stuff in 3D, especially for seismic and surfaces and things, comes up quite a bit, I thought it'd be fun to have him on and find out what he's about and how on earth he gets time to work on all these cool sounding projects. So hi, Bane.
Hi, thanks for having me today.
Yeah, no worries, welcome. So where are you?
I am in Golden, Colorado, at the Colorado School of Mines.
Okay, and you're a student there, or you're a...
Yes, I am a first-year master's student right now. I've been here for, I guess, going on 5 years now. I did my undergraduate degree here in geophysics, and did a minor in CS during that time, and just stayed on in the geophysics and hydrology program here.
Okay, cool.
Do you know what your topic for thesis is yet?
I am formulating that right now, but it all sort of is in this visualization realm. And how do we use visualization as a means of communicating findings in geoscientific problems? And how can we build a framework or build a tool set that geoscientists can use to inspect their data and to gain insight from their data and then communicate their findings?
Cool.
Yeah,
that is an atypical thesis experiment for a geoscientist, I would say.
I think so, and I'm excited to see where it goes. I'm excited to see you know, what kind of pushback I get on it, because it's not, you know, entirely geoscience, but it's very much something valuable to the geoscience community. So I'm excited to move forward with it. And
do you have buy-in from your advisors, et cetera? I mean, is there some...
Yeah. Formulating the committee right now, but yeah, I think there's a lot of buy-in here on campus, because people are realizing sort of the lack of tools available, or at least open tools available for researchers and geoscientists to visualize their data. And I think a lot of people here are realizing the utility it brings to just working on their projects and going back and forth on why isn't this inversion running right, and you know, looking at your model in real time and like just trying to figure things out. Visualization just plays a critical role in all of that.
That's great, and it seems like you can use your research while you're researching, right? So sort of disseminate it amongst the community and see if, you know, get user feedback or, you know, whatever you would call that.
Yeah, that's how it's been going.
What's the name of the tool? Is it PVGeo?
So there's a whole lot of these things going around right now. I have them all up on GitHub. PVGeo is where it all started. And so that was just sort of a whole bunch of VTK, visualization toolkit, VTK-based algorithms to sort of bring your geoscience data into the VTK framework, and also algorithms to do transformations on your data, things like coordinate conversions, or ways to integrate different data sets, you know, in sort of a context that makes sense for geoscience. So PVGeo is just sort of an extension package to the VTK suite of visualization software. But the thing I've been most focused on lately is VTKI, which is the interface to VTK, just a short Python package that calls back to VTK and makes 3D visualization really accessible and intuitive to novice programmers.
That's excellent. That's cool. So what kind of stuff are you running? So as you're developing, what are you testing against? What type of data?
So VTKI, that tool set's super general. It doesn't have to be geoscience. It doesn't have to be any specific data domain. It can be anything that's spatially referenced or has coordinates, whatever the coordinate reference frame that is. So we have a bunch of random sample data sets for VTKI, which we put up in an examples gallery on the documentation website there. Things like a triangulated mesh of a cow, or things like topography DEMs that are in 2D that we can like warp and filter and do things like that. So VTKI, we just super simple data sets, anything we can get our hands on that has a spatial reference. And then PVGeo, I try to find geo data sets, but that's been like my biggest hurdle so far is what data sets can I, put up on a repository and use in my tests and then distribute as an example, because everything in geoscience is closed source or proprietary, and that's been a huge hurdle for me.
Yeah, I think it just comes up again and again, doesn't it? Are you working? Is there like a team of you, or are you kind of a lone shark out there doing visualization stuff? Or because I don't pay all that much attention to the sort of subsurface visualization space, but I haven't been aware of anyone else at Mines doing that kind of stuff before.
No, I guess I've been more of the lone shark or lone wolf for a while, especially PVGeo. I started that during my undergrad and just sort of continued it. And I've pretty much been the only person to work on that. A few people have added a few features on GitHub, just it being open source. VTKI, however, that was initially started by Alex Kaczynski. He is just another researcher, not in the geosciences at all. So he started VTKI, and I sort of came on board and decided, okay, let's expand this. Let's make it super general. Let's work, let's truly interface the whole VTK library. And I've been sort of taking the lead on the development for that lately. And so it's pretty much just been myself, Alex, and whoever wants to make pull requests. And yeah.
Is Alex at Mines as well?
No, he is in Germany. He works, I think he's an independent contractor, but yeah, just I found his repo online and made a pull request and thought, you know what, this is easy to use. I'm gonna just expand it. And we just 4 months later, here we are.
Yeah, right. Interesting. So when did you I'm just wondering when you started programming and how much you've had to learn or teach yourself since you started. Because Viz is a whole other can of worms, isn't it?
Yeah,
had to learn a ton.
Yeah, I would say it was a struggle. It was a challenge at the beginning. I started all of this work in the visualization realm my senior year of undergraduate program. So that was almost 2 years ago now.
Okay.
And that was actually the first time I started working in Python. Before that, I did a bunch of Java development, C++, and then I switched to Python, fell in love with it because it's just an awesome language and it's really accessible and there's so many tools out there. So I learned Python, over the course of that year, and halfway through that process of learning Python, all of a sudden I was doing Python software development with PVGeo, and it was more or less just me trying to figure things out as I go, lots of Google searching, lots of reading very poorly written documentation on other libraries. And I really just had to get comfortable with that whole notion of just knowing absolutely nothing until you do.
But so is VTKI written in Python?
Yes, so VTKI is pure Python.
Okay.
And yeah, so the VTK library, they have Python bindings.
Yeah.
But those bindings are pretty much the exact same code. Like if you write Viz code in Python right now with just the VTK library, it looks the exact same thing or same way as its C++ counterpart.
Okay.
And so what we basically have done here is just inherited all of the types from the VTK Python bindings, expanded them, made them really accessible so you don't have to go through all these cumbersome routines that make sense in C++, but just don't make sense in Python. So we just expanded on that library a ton.
Okay, so you're not having to write anything except Python, and you don't have to kind of know anything about OpenGL because that's taken care of by VTK or the VTK.
Yeah, and all the OpenGL stuff, all that Viz stuff, it's really complicated that a geoscientist doesn't have time to dive into. Is all handled by VTK, and that was kind of the point I was getting at when I started all this. Is geoscience data isn't special. It's points, it's voxels, it's lines.
Mm-hmm.
There's triangulated meshes in geoscience. Like, it's nothing special in the realm of visualization. So why not use an already robust, tested, and expansive visualization framework for geoscience data? Like, we don't need to make our own special suite of Viz tools for geoscience data. So if we can just use VTKI or VTK through something like VTKI and then provide that link from VTKI to geoscience, then there we have a huge framework for visualization in the geosciences.
Yeah, I love that. Is there some notion of a finished state or a particular experiment you want to accomplish, or like what's the future state look like for this project?
Yeah, I don't know. I want to, I guess I've started this a little bit, get a bunch of geoscience related data, geophysical data, geospatial data for one very big project, and just create an example of, okay, this is what VTKI and PVGeo and like the other tools I put out there for all this Viz stuff can do if we bring them all together, and just have like a set of Jupyter notebooks up online that people can check them out and reproduce the same visualizations. So I started that a little bit on one of the repos next to PVGeo, where we have a geothermal site with a whole bunch of open access data that I've written like routines to parse the data as it comes from the geothermal data repository, get it into the data structures we want it in, and then it's in VTKI, and I have sort of a notebook that steps through like 5 different visualizations of all this data.
Yeah.
So I guess that's my goal right now, is I need to showcase all this with open data.
Cool.
And does so it sounds like your VTKI is also playing nicely with Jupyter. Is that right, in that environment?
Yeah. Okay. Yes. So everything works in a Jupyter notebook. That's how I do all of my scripting. Like if I'm working on a project for like school or research or whatever, I'm in a Jupyter notebook. But if I'm doing a software development, I'm in like Atom or I'm in an IDE. And so is every other geoscientist that I'm working with here at Mines. They're all in Jupyter notebooks doing Python. So I was like, this tool has to work in a Jupyter notebook, whether that means, popping up a separate visualization window outside a notebook. Like if that's what we have to do, then we'll do that. But we also have some rudimentary inline 3D visualization stuff going right now.
Is it interactive inline?
Yes. So we have.
Would you like render a JavaScript object, or how do you?
Yes. So VTK.js is a JavaScript library that's built on top of VTK. So brought the whole VTK library over JavaScript. And I've basically just I created an exporting script that goes from the VTKI rendering window that we have and exports to that VTK.js framework. The other thing is Panel and Bokeh. They recently did the same thing where they can take any VTK rendering window and then embed it into a panel frame in a Jupyter notebook. And so I've added some stuff on the master branch of VTKI that links over to the panel code. So if you have panel installed and you're in a Jupyter notebook, automatically the renderings pop out as an interactive inline 3D plot. They're rudimentary. They're not publication quality plots in the notebook, but it's a great way to rapidly inspect your data, see the results of a filter, and just move on.
Yeah.
Very nice.
That's really awesome. So it sounds like Python's taken off at Mines, because I always think of Java when I think of Mines. But that's changing?
Yes, absolutely. So I think the geophysics department here at Mines has gone through a lot of changes in the past year or two, and with that, a lot of technological changes, and realizing we need to jump on a Python bandwagon. So I think pretty much everyone here is working in Python.
Oh, wow.
And the MATLAB folks are still struggling to catch up, but they're on their way.
And and there are geologists writing code as well?
Yes
One or
and
two?
no. Yeah, a handful. I can speak for the geophysicists. I don't think I can speak for the geologists so much. I think that department, they're mostly still in the MATLAB space and all that.
Okay, yeah, but there's I guess a few folks that seem to be working with Zane Job
Yeah.
that I know are in Python, hacking around and doing some interesting stuff with logs and things that I'm interested in. So yeah, no, that's great. I mean, you know, we had, I guess, the first teams of students we had come to some of the early hackathons, like in 2014 and 15, came from Minds, and they left a real impression because they were so smart and such a great team. You know, they clearly wanted to have fun and do something cool, and yeah. But anyway, they just made a real impression on me. I was like, wow, Minds students are awesome. But they were all in Java at the time, because this was 5 years ago.
Because they were using Dave Hale's kit, right?
They were using, Minds JTK.
Yeah.
So, which, you know, I wonder, is that being ported to Python maybe? Because it seemed like it had some pretty cool stuff in it.
Yeah, I remember like 2 years ago I played around in there when I was doing a lot of Java development, but I haven't touched it since then. I don't know. Maybe someone is.
Yeah. I mean, I can't really read Java. Otherwise, I might be interested in having a go at that myself. But it's open source, right? I mean, it's most GKs out there.
Yeah. You know, I don't know if you guys typically do this on the show, but I could screen share and show what I was talking about the inline 3D viz.
Do it. I would love to see it. And what we'll do is we'll talk through it as you share, and
so
we'll describe it to listeners.
Yeah. What's even better is all of this is available for anyone to do on a binder. So if you guys want to do it as well, you can also pull it up. But I'll go ahead and screen share however we do that.
That's cool.
I've been brushing up on my viz skills myself. I've been getting my awful JavaScript a little bit less awful, and I started.
Okay, yeah, I saw you've been playing with D3. That's fun.
Yeah, I've been trying to do some stuff for customer projects because I feel limited with the canned, JavaScript output types of tools that we use in data science. Like they're great up to a certain point, and then they fall over because you need more functionality. And
yeah,
cool. You guys can see me, right?
We can see your screen.
See my screen. Sweet. So yeah, just to go back to what we were talking about a few minutes ago, all this inline plotting things working with Jupyter Notebooks. I've put together a on the VTKI site. So if you go to VTKI, you can go to our quick examples and go through a bunch of things that show off kind of what VTKI can do with just a bunch of sample data sets. So like here's that simple triangulated mesh of a cow I talked about. There's a training image for some geostat stuff. And yeah, we have all these examples. So what's really awesome is click the launch my binder and it will launch everything in my binder. We have open, so I'll just go back to it and you can just go in here, check out all those examples that are in the gallery that are updated in real time and play around with the notebooks. So yeah, you can be in a Jupyter Notebook, import the VTKI module. We have a whole bunch of example data sets you can use in the examples module for VTKI. And here in this line, I just I download the St. Helens data set. And then from there, I apply a filter called warp by scalar, which takes this 2D image that is my St. Helens data set, warps it so it looks like a realistic topography map. And then I can just say mesh.plots. I'm going to apply a linear opacity mapping onto it, and we'll see what that does. So I just hit Shift Enter and ran the cell, and it's talking to the server and figuring out what's going on. And here we are with a topography map.
Very cool.
Yeah.
So what we're seeing here for podcast listeners is an interactive inline visualization in the notebook. It's pretty awesome.
Yeah. Yeah, so I think this is huge. When I first got this working, I was ecstatic, and yeah, it's up and running. Anyone can come to this Finder, the hub, and interact with all of our examples.
Very nice. Can you show us an example of what it looks like for the pop out? So what additional functionality you get when you're not doing it inline? Is that simple to demo?
Yeah. Let's do it. Let's see. I have 1,000 of these notebooks with examples.
I see your tests are passing. That's good.
Yeah. Always want that. So let's think. What's a good example that has some volumetric data? Let's try this. So I've also put out another package called OMF BTK, which takes the open mining format and brings it all to BTKI. So I'm just gonna run through this example notebook I built for that project, OMF BTK. Have you guys heard of OMF?
Yeah.
What's his name? Rowan's team was working with that, right? When we spoke with him.
Yeah. So here I just use my OMF BTK library to read an OMF file, which is just like a project file full of data sets and whatnot. So here it is in the BTKI multi-block data set. And I can just go ahead and start visualizing stuff. And so I'm just grabbing data from that database, and there's some assay data. And here, let's create a pop-out window and do the split screen. So yeah, that was super fast. Oh geez. We'll figure out how to get Chrome to work. There we go. So there, that was that cell right there. I just did this BTKI threshold tool, which is it creates an interactive window right adjacent to your notebook, which is interactive while you code. So you can add things, remove things, apply filters like this threshold. There's a little IPython widget. I can threshold this volumetric data set. So just to show what it started out as, like a big volume of data.
Right. How much data is this that we're visualizing?
Like the size of the mesh?
Yeah.
Let's see. What this is that volume data, so I can just add in a cell. So I just plotted that volume object, which is probably a rectilinear grid, and it's got about 1 million cells, 1.6 million cells.
Nice.
And so yeah, let's that's cool. One volume thresholded. Let's add some more stuff to that. So I just added some grids to see my coordinate system. I can add some topo and some with a nice texture on it with satellite imagery. I got some fault planes in there, and yeah, let's add some wells. Uh-oh. Ignore that.
Live demo.
Yeah, whoops. I haven't touched this notebook in a while. So I probably broke something.
Very cool. Very
Yeah,
cool.
I love how you can just keep that window there and sort of interact with it from the notebook. That's really, really nice kind of workflow.
Yeah.
I think a lot of people, and myself included, I mean, the first thing I reach for visualization is Matplotlib, and it's not very satisfying.
Yeah, so, I mean, Matplotlib's amazing for 2D visualization. Their 3D viz is great if you're a pure data scientist, I think, where you're looking at, meaningless data when it comes to how it's spatially referenced.
Yeah.
But yeah, if you want to do things like look at geoscience data, I don't think Matplotlib can cut it.
No, this is
very nice. So I'd give you a master's degree for that.
Well, that's what I want to hear.
Very cool. So how does we have a note in here about AR and VR? Do you think are you wedging the AR VR buzz into this project?
Yeah, maybe this would have been a good discussion point to have at the beginning, because this is how everything started here. So when I was an undergraduate starting to get working on this, my current advisor, she reached out to me at the time and told me she was interested in bringing geoscience, bringing geophysics into virtual reality. That was kind of like, that's all it was. And we were like, yeah, it's a great idea. Let's bring geophysics into VR. And then I tried it, realized I know nothing about visualization or virtual reality or anything. And that's how all this started. It was like, okay, I have to provide that link to get geoscience data, one, visualized, and then two, be able to send that visualization to VR. And luckily, VTK and ParaView, which is just, ParaView is just the graphical user interface to VTK, they support VR already. So once you can bring everything into this VTK realm of data visualization or model visualization, then you can just send it over to VR with like a few clicks of a mouse. That's how all this started.
That's fascinating. So do you have a rig? Do you have a VR setup in the office that you can test some of this stuff in?
Yeah, we do. Yeah, and I have some videos of me flying around in VR with some geoscience data online on Vimeo and on the PVGeo website. So yeah, so PVGeo, the PV in there stands for ParaView, and then Geo for geoscience. Yeah. And that's why I started making PVGeo, is let's get all the geoscience data in the ParaView. And once it's in ParaView, you can just click a little button that says send to OpenVR, and that sends it over to your HTC Vive if you have it hooked up. And so we have a nice gaming laptop and an HTC Vive, and we've done quite a bit of VR visualization of geoscience data.
Are there who's using your various toolkits, VR included, in their workflows? Is there a group at Minds that's using this stuff now?
I have a handful of sort of like colleagues and friends here that are using like VTKI and PVGeo here and there. It's been sort of slow to get people to adapt a new tool, just because one, you have to learn something new while you're already busy, and two, I'm fixing bugs and things like that all the time, so that can be frustrating for a novice programmer or someone unfamiliar with the library. As far as anyone using the VR stuff, it's pretty much just been me. It's been we're trying to figure out a use case for it. We have the equipment, we have the software. We just don't really know what to do with it at this point, because it's been really hard to find a way that VR sort of adds a scientific benefit to your research workflow. It's been kind of gimmicky. It's I think so far it's been a really good tool for just communicating to the non-scientists what we're doing.
Exactly. That's what I was going to suggest.
Yeah. So that's where we've used it the most, is just trying to communicate to project planners or just people without the geophysics background or geology background, sort of what subsurface data means. So it's been really useful to get the VR set up, throw some topography data in there, throw like wells, throw a subsurface resource model or geostatistical model of some sort, put it all in the VR, and then hand that headset over to someone, and they can fly around in it, and they start to really gain a perspective of what that data means and why maybe decisions were being made. So that's sort of where we've gone with it, but it's been really hard to prove its worth in like a research workflow.
It seems like a lot of the folks I've met who seem really interested in AR and VR are in the sort of virtual outcrop area. Is there I'm sure there's someone of mine's who's into that kind of thing. Have you played around with that sort of data yet?
Like AR stuff?
Yeah, AR and I feel like VR as well, but constructing outcrops and also being able to, because I guess the interesting things to do there aren't just like making the visualization of the outcrop, it's then like integrating it with, say, structural data or mineralogical data or hyperspectral imaging, those sorts of things, which can be quite difficult, I guess, to integrate that with a bunch of 2D displays. They make much more sense in 3D stratigraphy as well. So I haven't seen anybody, like all I've seen is people reconstructing basic, with just LiDAR and photography. But I think those are prerequisites to getting to that next level, where you've actually got all this other data to integrate. But yeah, I mean, have you played around with that sort of stuff at all?
I've tried. I haven't played around too much, and I'm not too aware of many other people doing it. Just sort of hasn't been the space I've been in, I guess. But yeah, I mean, if you have data, we can put it in the VR. So
right.
it used to be non-trivial, but now at this point, it's pretty straightforward to get it there.
Right.
Yeah.
No, there was a team, I guess most of the team were from a consultancy, actually in Germany. But they were doing AR with virtual outcrops at our hackathon last year in Copenhagen, and doing things like putting the outcrop sort of on a table, at a sort of room scale. So it was all about, it was two things. They wanted to get the scaling right, and then they wanted to get the multiple simultaneous viewpoints so that different people could kind of walk around the same object, point at things, and for that to make sense to both of them, sort of thing, from their different points of view. There's a video floating around, I think, in our hackathon report. But like I say, the really interesting stuff is in the sort of analysis that comes later that might not itself depend on visualization, but I think making sense of the results of the analysis will only make sense when you can see the data all together.
Right.
So yeah.
Call to action on Software Underground, I think, is in order here.
Yeah, I think of 3 or 4 people on Software Underground who are definitely interested in that space. And I don't know if I dare talk about it in public, but the computational field camp idea is back on the table. So we're hoping it was. So Bane, this was a thing that I bailed on last year. But the idea was to do a hackathon, but in the field, with drones and GPR and hyperspectral cameras and stuff like that. Yeah. So basically, 50% kind of geeks with laptops and 50% geeks with spanners and monkey wrenches or whatever. And I know who all those people are. And maybe you're one of them. I think your Viz stuff would fit really well into that.
Yeah.
Anyway, it's going to be in Spain next spring.
I will hold my breath.
Yeah. For now, you should probably hold your breath.
Yeah.
But, that's
cool.
It's got to happen. It's a thing that has to happen. So
yes,
we just have to make it happen. That's all.
Yes. Yes. I wanted, before we run out of time, I want to hear about a little one-liner note that you put in the show notes, Matt, about hanging on Markov chains to stay sane. That doesn't seem like the thing that would keep people saying, what's the story there?
Oh, I know. Well, actually, so it comes back to this strip log tool, which Thomas Martin and Jeff, I can't remember his name, another chap at Mines have been hacking on a bit recently. And the question has come up a couple of times too on Twitter. People are like, what are people using for stratigraphic columns and sedimentary logs and representing stuff like that? And we wrote this thing, strip log, for doing that. It's got horrible visualization, Bane. It's very sort of rudimentary. But one of the things you'd like to be able to do with these sedimentary logs is analyze the sequence in some way. So, A comes after B, comes after C, and specifically, you'd like to know, is there some sort of organization to those sequences? and what is that organization. So this is sort of what stratigraphers do with intuition, and what you'd like is some computational kind of backup, I guess, or other ways to explore those sorts of questions. And Markov chains have been used for that for quite a while in sedimentology. But as with a lot of things in geology, these tools are in the hands of sort of non-statisticians most of the time. So people do slightly wonky things with them. And there is a kind of established best way to do it. So I thought I'd try and code that up from this paper from 1982 or something. Once you've got the Markov chain stuff working, you can do a couple of things. You can make a graph with weighted edges where the weights correspond to the degree of, essentially it's how unusual is this transition compared to the transitions that you would get in a random sequence with the same proportions as the sequence that you have, if that makes sense.
Sure.
So you sort of, you look at what you've got and you compare it to a random sequence, and where it's substantially different, you can sort of say, well, that's unusual.
That's information.
That's information, exactly. So you can make a graph out of that. I'm really interested in that because once you've got a graph like that, you can use that potentially as a cost function if you're trying to predict these sequences. And, maybe it can play with some sort of machine learning, sequence learning algorithm later. But yeah, it's a bit of a black hole. There's hidden Markov models where some of the states of the system are unknown, essentially.
Yeah.
So you can try to model things that way. There's also, you can sort of say, well, maybe the state of the system doesn't just depend on the last thing, but it depends on the two last things or the three last things. So you can kind of have this memory kind of concept. So this will keep me busy for... But why to stay sane? It was really just because otherwise, sometimes at the moment, I feel like I'm just doing busy work. So if I'm making a few commits to a GitHub repo from time to time, I at least feel like I've contributed something to the world. I don't know.
Good. Well, I'm glad that you're on it.
Something to do, isn't it?
It is. We always have a question at the end, which we ask all of our guests, Bane, and we're going to do that in 1 second. And before we do, however, I want to make a note to the rest of the software undergrounders who may be listening to this show. I am planning or attempting to plan, if there's any interest, a meetup in Austin. So if you are in or near Austin and want to come hang out with some other software undergrounders, that is a thing that we're going to make happen at some point in May. So I'm open to dates and preferences and interest. So find me on Software Underground. Matt, you didn't write the question in here.
Yeah, no, sorry.
I like to have it in here because I like to put links to the reference material.
Yeah, good. Well, let's start with Bane. What are you reading at the moment? What's on your bedside table? Book-wise, I mean.
Oh.
What else would it be? Like a milk carton?
Yeah, grad school hasn't been sort of facilitated much casual reading.
just a bunch of casual data viz programming.
Yeah, to be kind of frank, there's usually an iPad with code documentation websites pulled up next to my bed.
Yeah. Can identify it. Well.
Yeah, I think I was reading a Western sort of historical novel. I forget the name of it right now. I'm completely blanking, but yeah, just I was reading a Western lately.
Huh.
Yeah.
A contemporary one, like I would never for a Western. It wouldn't even. It had, so I don't really know anything about that genre, but
it's a book about sort of a Western history in the U.S.
okay. I see.
Yeah, so like cowboys and Native Americans and that whole realm of history.
Right, like fiction or nonfiction?
Nonfiction.
Okay,
The
is that
factual.
you would generally read nonfiction stuff?
Generally, yeah.
Conversation, history of the United States.
Yeah.
Yeah.
Matt, what are you reading?
I'm also reading some nonfiction.
Oh man, I thought you were going to say I'm also reading some Western.
No. No, I'm reading. It was a bit of a sort of impulse purchase on Kindle. I don't normally read on Kindle. I've got Kindle on the Kindle app on my phone because I've got a few old Kindle books, and I was like, well, I should probably read these at some point. After I lost my Kindle on the plane ages ago, I sort of forgot about it, and then I thought, oh, I could put it on my phone. It's not the most satisfying reading experience in the world, I must say. But on the other hand, it's better than just aimlessly scrolling through Twitter. At least I think it is. So I must say, just as a sort of tangential side note, I find Twitter increasingly, well, let's not put it that way. I find it decreasingly useful.
Okay, I agree.
You really? You do?
I do. I made a push this week or past 2 weeks to interact more with Twitter because my involvement in that Twitter community has dropped off a lot. I've just kind of lost interest. So I'm trying to re-engage.
Yeah, I can't quite put my finger on what's changed. Maybe I've changed. Like maybe it's not you, it's me. But
no, it's happened to 2 independent personalities at least.
Yeah, maybe. Yeah. Well, good. I mean, not good, but I mean, that makes me feel slightly less curmudgeonly. I've deactivated my Facebook, and I think I'm deleting it next. So I don't know. I don't want to be completely isolated. Eventually, it's just my only social media contact is my blog, which I type with my fists. That's great. Anyway, so what I'm reading is Seth Godin's latest. I haven't read Seth Godin for a long time, but it's called This Is Marketing. And it's not, it is ostensibly about marketing. He's a marketer, but it's also about, culture really, and, communities, I would say. And I really like his core message, which you get in the first 10% of the book. I feel like you could read the first 10% of the book and then basically the rest of it is sort of churn on that idea. But I like everybody in oil and gas marketing needs to read his stuff because marketing in our industry is just vapid. We've gone on about that before, I have. So I'm sort of quite enjoying it, but I think I might stop reading. I guess
you're past the 10% mark. You're good. So I'm reading a book right now that's called The World Without Us by Alan Weissman. It is
depressing.
It kind of is. It's kind of a treatise on what happens when humans aren't on the planet anymore. I'm not totally sold yet, but I did want to mention, I can't recall if I mentioned this in the last episode or not, but I just finished a book called Never Home Alone, which I thought was really fascinating. So that one is about all of the creatures that live inside of our homes with us. So you'll have to wait until next episode for me to get through The World Without Us to give you a real recommendation. But definitely Never Home Alone is awesome.
Yeah, okay, that does sound good. I think my wife would enjoy that as well.
Cool.
because we have 3 massive bugs in this house.
Okay, well, thanks, Bane, for joining us on Undersampled Radio. Hope to have you back.
Yeah, I totally want to see where your research ends up, because you've done so much already and created some amazing looking tools. So I can't wait to see what happens when you go around applying them to all sorts of different problems.
Yeah, I look forward to expanding on it, and I'd be happy to share some more when we, develop it out. And thanks for having me on the show today.
Excellent. Thanks, everybody. See you next week.